For the following practice, we were asked to create a program using the PT100 sensor that through operational amplifier condition the signal so that the temperature can be measured in voltage using the Arduino board and display the voltage and temperature values in LabVIEW. When the sensor reaches 100 degrees centigrade, the voltage must be stay at 5 volts. And as the temperature decreases, the voltage will drop proportionally. The voltage and the temperature value will also be stored in the text file along with the date and the time where the data was captured. On the front panel of the programs, a graph will add a waveform graph which will update automatically as the temperature increases over the time. A thermometer was also added to display the sensor's readings. Three indicators LEDs were added as well, which through value comparisons will show whether the temperature is cold, ambient, or hot. To control time, a numeric control was added along with two controls to allow the user select to serial port where the Arduino is connected and the pin where the sensor reading will be received. Finally, two numerics indicators were added to display the measured temperature and voltage as well as store buttons, one to enable data saving and one to the stop simulation to save the data and stop the simulation. As the first step in the development of the programs, a while loop structure was added which will serve as the main structure of the program. To be able to measure with the PT100 sensor outside the main structure, the Arduino connection open and close blocks were first added with their respective constant. For the reading process, new blocks were added. First, in the SPI, this block, the SPI open point BI blocks forwarded by a SPI configuration tab. A consonant was added and configured with a million in the first field, MSB first in the second, and mode 0 in the last. Inside of the structure, the SPI read block was added, in which under the data tab, a constant will added and all its values set to 0. At the top of the block under the CS configuration, tap the constant as added and connected with the control where the pin for reading data will be selected. Sorry. And this is the connected to bullet by name block, which inputs the configuration data to read-write blocks. The options chosen were 10 in the first row and active low in the second. Once the sensor read-write blocks is configured, its read data output connect to a block called index array, this block, which will provide two results. Each result connect to the corresponding converter converter coded number to Boolean array. The signal is split there. One goes to the block called reverse 1D array. The other goes to an array subtract block with a constant value of 3. This part continues to another reverse 1D array block which later joins at the first signal to the insert into array block. Here both values are combined and passed through a Boolean to number converter and then to a double number converter. This final signal is multiplied by a constant of 0.2024, and now the result can be considered our temperature reading. Comparisons are made to the lights of the LEDs hot above 30.01 degrees centigrade, ambient between 10.01 and 30 degrees centigrade, and cold below of 10 degrees. The obtained signal connects to the respective LED to show in each temperature range the sensor is, as well as to the graph that will show the temperature on the thermometer. Next, a small comparison is made ensure that if the temperature is greater than 100 degrees, the result remains fixed. To avoid measurements result issues, this signal is also connected to a real-time temperature monitoring graph. This. If the result is to calculate the voltage, a division is made between the measured value and 100. This part. If the result is greater than 5 volts, only the maximum allowed value, 5 volts, will be shown. A timer was added along with its respective numeric control to manage the timing. Also, the loop conditioner is connected to both the link's error conditioner and the stop button joined by a logical OR gate. For the data collection, a case structure was connected to a save button be in its case selector. When the case is true, the following is added. Outside of the main structure, to start by create a new document, the build path block is added with two constants, one for the directory and one for the file name. Next, the delete block is used to delete the file if a new one is created. Then the open create replace fail field blocks is added with two constant, one create under the operation tab and write only under the access tab. Inside of the main structure, to continue, the write text file block is added, which allows reading to the file to decide what information to be included. The data and the time block is using this part, along with a concatenate string tool that same blocks that converts numbers to strings, number fractional to strings, which are connected to previously obtained results. with a variable, local variable. Some constants are added to organize the text formal to the results. And finally, a block called uh, current return constant is added to end the line to create a new one automatically. Outside of the block, to finish the file creation, the close file block is added, which close the document after the simulations end. In the false case of the case structure, its inputs are simply connected to the outputs without performing any operation. Thank you.
For the physical assembly of the project, the corresponding connections are made between the Arduino and the PT100 sensors. Once everything is connected, testing begins. And at first, it displays the ambient temperature. However, as the sensor is exposed to heat, the values on the graph and thermometer rise sharply until reaching the highest value.